In this video, we will explore optimal page replacement algorithm. Optimal page replacement algorithm replace page that will not be used for the longest period of time. The optimal algorithm associates with each page the time when these pages are accessed. The optimal algorithm guarantees the lowest possible page fault rate for a fixed number of frames. So this is a optimal page replacement, very good performance. But the disadvantage is it is difficult to implement this optimal page replacement in operating system because this algorithm requires the future knowledge of the reference strings. This future knowledge of reference string is unknown before this process complete running on the CPU or complete all the execution on the CPU. So the future information is unknown, so we cannot implement this page replacement algorithm in operating system. But we still can use it to for the comparison studies and measuring how well page replacement algorithm performs and compare this algorithm, the new algorithm with this optimal algorithm. Now let's take a look at an example of optimal page replacement algorithm. So we use the same reference string. We use the same reference string. This is a 70120. So the process access page 7 first and then 0 and 1. So we associate with with this access time for each page. That means page 7 is accessed at time 1, and this page 3 will be accessed at time 6, and page 0 will be accessed at time 11. And now I will show you the optimal page replacement. At time 1, 2, 3, so we have 3 page fault. So we load the page 7, 0, and 1 to the memory. So this 3 page fault, but we don't need the page replacement because we have free frames. And now at the time 4, the process need to access page 2. And now there's no free frame. We have the page fault and we need the page replacement. And now we use an optimal page replacement algorithm to select the victim page. Now we take a look at the page 7. Page 7 will be accessed at time 18. So this is the time 18. And the page 0 will be accessed at time 5. So this is the 5. And page 1 will be accessed at the time 14. So we look at the future information about this reference string. When this page will be accessed in the future. So we get this, assuming this future information is known. So we take a look at this this information. And now we can see the page 7 will not be used for the longest period of time compared with the page 0 and 1. So page 7 will be selected as the victim page. So page 2 replaces page 7. And now the page 0 and the page 1. And then page 0 is in the memory, no page fault. Page 3, there's a page fault and we need the page replacement. And now we can see the page 2. Now we need to select the victim page. Now the page 2 will be accessed at, I will write down here. Okay, now page 2 will be accessed at time 9. Page 2 will be accessed at time 9. And page 0 will be accessed at time 7. And page 1 will be accessed at time 14. So now the page 1 will not be used for the longest period of time compared with page 2 and 0. So page 1 is a victim page. We use a page 3 to replace page 1. And then the page 0 is needed. Page 0 is in the memory, no page fault. And then the page 4 is needed. Page 4, we have the page fault and we need the page replacement. Now in the currently in the memory, we have the page 2, it will be accessed at time 9. Page 0 will be accessed at time 11. And page 3 will be accessed at time 10. So now the time 0 will not be accessed for the longest period of time because 2 will be accessed next at the time 9 and then 3. So we use a page 4 to replace page 0. And now the page 2, no page fault, page 3, no page fault, and then page 0. Page 0, we have the page fault, we need the page replacement. Now at time 11, we need the page replacement. Page 2 will be accessed at time 13. And page 4 will not be needed anymore. And page 3 will be accessed at time 12. So page 4 is a victim page. We use a page 0 to replace page 4. And then the page 3 is in the memory, and the page 2 is in the memory. No page fault, no page replacement. And then the page 1. Page 1, now the page 1 is not in the memory. We have a page fault, need a page replacement. Page 2 will be accessed at time 15. Page 0 will be accessed at time 16. And page 3 will not be needed in the future. So page 3 is a victim page. We use page 1 to replace page 3. And then page 2 in the memory, page 0 in the memory, page 1 in the memory, no page fault. And then the page 7. Page 7, we have the page fault, need the page replacement. And page 2 is not needed anymore. So the page 0 will be accessed at time 19. Page 1 will be accessed at time 20. So page 2 is victim page replaced by the page 7. And then page 0, page 1, no page fault. So now this is the optimal page replacement. Now let's count the number of page fault. 1, 2, 3, 4, 5, 6, 7, 8, 9. So now we have 9 page fault. If we compare the force in, force out, and the optimal, the same reference string, but the force in, force out, we have 15 page fault, and optimal, we only have 9 page fault. So we can see the optimal algorithm is much better than the force in, force out. But the thing is, it's impossible to implement this in the operating system because this future knowledge of reference string is not knowable. It's unknown before this process runs on the CPU or before this process terminates. So we only can use this for the theoretical comparison study, not implement this in the operating system. Okay, this is all about the optimal page replacement algorithm.